morning to all, good afternoon to all, depending on which time zone you're in. My name is Kevin Graham. I'm the TCCA CEO, and it's my pleasure to be able to host the session today, brought to you by our local chapter in Australasia for the Critical Communications Forum. So thank you for all attending, and we will be going through a number of sessions in respect to the latest in critical communications. For all of you that are watching the screen, I will introduce our presenters at the start of their presentation. We will be taking a short 5-minute break following the presentation by Rory Mcdonnell. We will also be asking you, if you have any questions, you may post these during the webinar using the question and answer panel on your screen, and we will endeavour to answer these questions at the conclusion of the presentation by Neal Richardson. So thank you again for attending, and I hope you find this this next instalment of the Critical Comms Bitesize webinar informative and insightful. There is lots going on in our industry, and there's lots of things to keep up with, and we're very pleased to have key members from our membership, from our industry representatives, and also from our end user community and operator community who are engaged in both the ongoing provision of narrowband networks supporting our public safety and government agencies, and in the process of enhancing that capability with critical broadband. So again, if you have any questions, please post them during the webinar, and we will answer those at the conclusion of the last presentation. Without further ado, I'd like to introduce Peter Scarlata, who is the CEO of Smoko Wireless Solutions, an active member in the local forum, and also actively involved across the globe with the work they've been doing in evolving technology. So over to you, Peter.
Oh, thanks, Kevin. Really appreciate it, and very happy. Good afternoon in this nice sunny day here in Melbourne. So I hope everyone is well. Anyway, today I've got a bit of a mouthful of a topic: new and evolving technology standards providing new concepts in critical communications, LMR, LTE, hybrids, 4G and 5G. Gee, it's almost an essay just in the title, isn't it? But it's a very interesting time coming into this time of broadband. So let's get into it. Let's see if we can get the technology to work. Here we go. So if we have a look at my first slide, and the first thing you see there is an increasing demand for data-driven applications. And both commercially and in private applications, it isn't a surprise to see that the thirst of data to power new applications is growing rapidly. And you definitely see that across this screen with all the different types of areas that require lots of data. And even in the mission critical space, where we as members of the ACCF operate, we are finding that our traditional customers in public safety, mining, government are requiring greater data pipes, which are far in excess of the narrowband data that traditional radio can deliver. Hence, we are now in very interesting and exciting times for us communications engineers, where we are using our years of RF experience to actually introduce new high-speed data technologies to provide pipes for devices like body-worn cameras, IoT edge computers, and even integrating our traditional mission-critical radio functions into 4G and 5G platforms. So, however, due to the mission-critical nature of the systems that we work with, the vast majority of agencies won't make the direct jump to LTE voice communications. What we are seeing is a much greater appetite to run LTE for data-rich applications and traditional radio in parallel. FirstNet in the USA is a direct example of such a strategy. However, what we are also now enabling is the convergence of LTE and traditional radio as a smooth transition to mission-critical broadband networks. Such mission critical networks, like the PSMB in New South Wales, have been successfully trialled as has been well publicised. So it's imperative as a communications manufacturer that we here at Simoco look to the future and expand our products and services to enable seamless communications between dispatchers, radio networks, and the LTE world. This means traditional group and individual voice services are now extending into smartphone and LTE-enabled vehicle devices, which also provides scalability from small to nationwide services. A year ago, you may remember me introducing and talking about our new in-house and Australian-designed product called Velocity. Velocity has been the key for Simoco to introduce hybrid networks to our customers. Velocity is a Linux-based smart LTE communications hub that, when connected to our STM600 series radio and satellite bearer, will automatically roam to the bearer with the best signal quality to keep you connected. However, as well as Velocity being a communications hub, it is also an IoT edge computer. Many of our customers have used Velocity standalone without a radio connected at all to monitor inputs, serial data, sensors via its inbuilt Bluetooth or Wi-Fi, and via its user programmable logic Node-RED perform automation functions. Here is an example of how Velocity automatically switches over. In this case, Velocity has been configured to operate with our STM600 radio again, operating in DMR mode. The vehicle on the slide is outside of the DMR zone, so it is conducting a DMR code through the LTE network back to the base DMR network. The user in the vehicle is completely unaware that this is happening, unless they're astute enough to notice the LTE symbol that has come up on the display. It's completely seamless. The other advantage of Simoco DMR is that it fully supports full duplex calling. So it's possible to set up your DMR network with full duplex, and this functionality will continue outside of the DMR network via LTE. So here at Simoco, we're taking converged networks pretty seriously. As mentioned earlier, we are bridging the worlds of LTE, LMR, and satellite. Over and above that, we're also converging IoT and data with the integration of Wi-Fi, Bluetooth, vehicle CAN bus, and other sensors such as accelerometers. This is enabling a feature-rich data set that is providing our customers with flexibility and more monitoring than ever. Our converged strategy has also moved into our one of our first fast deployable products, I should say. Last year, we released our first fully digital deployable radio network. The big advantage of this product, which is called Morph, is that it passes voice and in-band data digitally between P25 and analog radio. This means that various radio bands in P25 or analog can all be joined together, passing voice and data between them without any loss of voice quality across an infinite number of hops out in the field. When combined with the power of Velocity LTE, we can even pass P25 data over the LTE network to utilize the data in many ways. So we see that it's clear that mission critical 4G and 5G is here to stay, and it's having a great impact across the world. Not all networks are rolled out yet, like the Riesen in the UK, for example, or on the way to being rolled out. But we can see the great investment by governments globally in deploying these mission critical 4G networks. What we're seeing in the main is that these LTE networks will coexist generally with dedicated narrowband networks until broadband is trusted and ultra reliable and is available everywhere. I've spoken a lot about the convergence of LTE and radio, but here is a Simoco sister company called Thorcom, and an example that they have of existing customers of ours in the UK, serving the UK ambulance market. As stated on the last slide, here we see the 4G network, or really the aggregation of several 4G networks of a life-critical service. Our Simoco EC950 in this case is used as a smart vehicle router to provide ultra-reliable broadband connectivity to the ambulance by up to 16 bonded different data streams, as well as providing operational control via the MDT. This is a great example of where 4G in this case has successfully taken over all of the ambulance data applications, and narrowband is operating in parallel for voice comms. Smoker is also working on mission-critical push-to-talk solutions to complement our well-established narrowband options for the future. So in summary, what we're seeing is 4G is having a great effect globally on providing public safety with real-time data applications. Here at Smoker, we believe that LMR and LTE will remain complementary technologies really for some time. We also believe that Kodiak and other broadband push-to-talk MCPTT are complementing LMR, and that's what we're already working on. Here at Smoker, especially with the acquisition of Thorcom, we have 25 years of additional LTE experience in LTE communications, which has enabled us to have a wider reach and expanded product range. And because of that, we also have our 4th generation devices aligned with national government requirements. That's all from me for today. And I think it's back over to you.
Thanks very much, Peter. It's with pleasure now that we will hand over to Dion Stevenson, who is the product manager for Unified Solutions with Tait Communications. So without further ado, over to you, Dion.
Brilliant. Thank you very much. It's always a pleasure to talk to a whole pile of people. It's I always enjoy being on the stands and discussing, because I find it's been great to be at the coalface. But what I'm going to bring to you today is to talk about, and I've entitled it RSM because it kind of defines the form factor a wee bit for us. But you know, we've done some cool stuff inside that. So within that, this product sits under our Tait Axion range. So the Axiom is our umbrella marketing term for our LTE solutions and products. And so the wearable fits within that. So we've called it the wearable, a long-standing, I guess, perspective on things. This is because it's something you can put up on your lapel and shoulder. It's not like a portable, but it's somewhere sort of in between. But the idea being is, look, we want to communicate, and the idea is we want to go further with confidence. And cool. Skip a few slides. So the wearable is another device in a range of pieces of equipment that fit under the Axiom. They all use LTE in some way, shape, or form. And we've got our Axiom Mobile, which is our edge computing platform. It's got the DMR inside of there, as well as the ability to use Node-RED to do some local programming. It's got your Ethernet, which you can bring through to satellite. You've got your Wi-Fi and your Bluetooth and all that sort of stuff in there. At one end, on the other side, you have your handhelds, your Android applications. iOS is later this year, and that is designed to hook into this whole ecosystem under the Axiom. And we have a few branches within Axiom, a few different endpoints or technologies. We have radio, you have DMR, P25. Take that sort of thinking, and then you can bring it through to here, and we call this PDToX in this instance, and we've got some other streams coming out as well. And so PDToX is designed to handle that whole multi-bearer situation as a bit of a backdrop. But you know, for me, I like stuff to be people-centric. At the end of the day, it's about humans. It's about them being able to communicate. It's about them being able to operationally connect. And in terms of use, it's also about being intuitive. And one of the things that we have certainly found in the marketplace is that a lot of people come at the whole radio LTE problem from a LTE perspective, and there's not many of us coming at the problem from a radio perspective. So that is significant in that it brings across the radio operations into the LTE world, and we're finding that is particularly helpful for people, and for a number of reasons. So the wearable, it's small, it's cute, it's sitting about sort of 7 centimeters high. It's a little wee, it's about 2.5 centimeters wide, and thin on the side, I should say. And on the front there, it sort of looks and feels like a radio. And of course, it's been designed by Tait, made in Christchurch, and it's a compact and a very rugged device that's got all the goods. So on the inside, we've got the LTE cellular, and we've got 3 variants sitting across the world. There's the American version, there's the Australian, New Zealand version, and then there's the European version. And on the inside, of course, you've got that LTE module. There's the Bluetooth, the GPS module inside that. And we've catered for eSIM as well as nano SIM. And so we're finding that is a good move, because there are a whole pile of people that want to manage their networks via the eSIMs, and we realise that we're probably at the leading edge of that. And there's lots of discussions with carriers around how that actually works in practice. So looking at the side, there's the dimensions there: 34 deep, 72 high, and 102 high and 72 wide. And so it's got the traditional buttons that you'd expect from a Tait product. It's got the big fat PDT button with that nice feel when you press and acknowledgement. You've got the blue function button, and then at the top you've got this nice little wee color display, so allowing a user sort of to look down at the unit to work out what's going on, who's talking to them, what channel they're on per se. Not that maps nicely, and then your battery and which bearer you're using, so LTE Wi-Fi inside this unit. And so it's also ruggedized as well. So it's all about trying to bring anyone into that conversation, right? No matter where they are sitting in the field, whether they're working in an office, working out in underground or above ground or in a vehicle, or they don't actually maybe have a radio device at all. It is just purely LMR, purely LTE. This is trying to bring those two worlds together, that whole convergent story that we're all interested in now, and we're seem to be deriving at a common understanding of what that actually means. And so having a device like the wearable that's just LTE only is another tool in the toolkit that people can use to bring about that communication for people. But we've also got another trick up our sleeve with this particular unit, and we call it tethering. So you can take a Tait radio, DMR radio, for example, or a P25 in the future, and tether that to the wearable. And suddenly your portable now, which provides you that radio DMR coverage, is now extended to use the LTE as well. And if you happen to run out of power, for example, on the wearable, then it acts as an RSM. It acts as a traditional speaker mic. And so all of a sudden for a user, they've got 2 paths of communication. They can put that on their body, have the portable down their back as they traditionally do. And from the wearable, you can use the volume knob, and that controls the volume on the radio. You can select through channels and things like that. And of course, you press your PDT button, and it does what you would expect. And so that's a really, really cool feature, we feel. So it's a bit like our unified vehicle, traditional radio, the edge computing platform I was talking about. And it brings that capability through to a portable that someone wears on their body. But that's only part of the story, of course. LMR interoperability is huge. So many systems that I'm aware of just do one thing. They pass the voice, and maybe they'll pass a bit of user ID through. But with our PD2X under the Axion branding, you've actually got a full-featured radio toolkit at a network level. So things like location services come across, and messaging, emergency alerting, text messaging, status messaging, all those things that you would expect to see on a radio-centric device are there within the capabilities of the Axion platform with these devices. So that's huge. So suddenly things like priority overrides and things like that all work. And we go, well, why is that massively important? Because for an organization, it means they don't need to retrain their staff. They can drop this device in their hands, and they go, oh, this just looks like a portable. Oh, there's the PDT. Oh, I get this. It happens very quickly for them. It's intuitive. And we think that it's a great win for people and for those who need to support products, for those that need to work with people in the field of all sorts of levels of capability. We think that it makes life a lot easier. And of course, the interoperability with the smartphone applications, that application as well also looks and feels like a radio device, and acts and behaves in a similar way. Similar sort of thinking, terminology is brought through to that level of actions that the device can use. The up and down arrow is not working too well for me. So then just to expand on just beyond the voice, there's that press to talk, there's that text messaging, there's that emergency alerting, location sharing, the LMR interoperability, and of course over-the-air programming, which I haven't touched on yet. So it uses our enabled fleet capabilities. So if you've got lots of Tait devices, we haven't invented a new thing there. We use our current technology to push that over the air. So your updates go over the air, no matter which bearer you're on. Of course, if you're using a radio bearer, it takes a little bit longer with some of the data because the data pipe's only so big, but you get the advantages of a big data pipe. And as was previously discussed, the need to share data is huge. And with the tethering and a network that has LMR as well as LTE, you can use the benefits of both. The voice wins in the LMR world, it always gets through, but we can back that up with the decent data pipes coming through from the LTE world. And so it's not a question of course which one, it's a question of how do they play together and make sure that they play really, really nicely. Thank you very much.
Thank you very much, Dion. And I think that's a really good introduction on the way in which industry is responding to demands from users. And it's great to see the connectivity and the unification that's happening both within the LMR side and the ability to integrate with the LTE and critical broadband capabilities. It's with great pleasure now I'd like to introduce Colin Bresnahan. Colin's has been in the industry for many, many years. He's a senior business development manager with Sapura. And I'll hand over to Colin now to explain what it means to be mission critical. Thanks, Colin.
Thanks, Kevin. Yeah, welcome all. A couple of great presentations from Dion and Peter. I guess what I'm going to present here is probably taking us back a couple of steps, back to something that we need to make sure that we keep forefront of all this, and that is what is mission critical. Let's see how these buttons work. Okay, so the challenge we've got today, mission critical and business critical communications, they rely on dedicated networks, high grade of service and availability, reliability and security. They're designed to cater for geographical coverage, service design for command and control operations, and they focus on group orientated services, so voice and data. So the end users have relied on these voice services and they'll continue to do so. Excuse me. They have evolving operations and with their data services and applications. Many of these can be carried over their current LMR Tetra networks, but there is a need for video and high-speed data. Capacity calculations for these networks, the difference between Tetra and LTE networks are quite different. So Tetra delivers the same level of service throughout the whole cell. The Tetra can deliver a group call to many participants using single Tetra channel. With LTE, the cell edge has got to be dimensioned for a target level of service. The cell has to be dimensioned to many unicast bearers, this can impact the cell capacity. Control. Organisations, they want control of their communications assets. They demand detailed audits of their entire ecosystem. They impose specific security features on the equipment. These are protected against threats from, and they need national security demands. Protecting confidentiality and the information that they're using. Quality of service. The mission and business critical users, they need an assured quality of service from their communications that guarantees communications is always available when it's needed. This is dependent upon the design and implementation of both the devices, applications and the network to provide an unfettered real-time access. Whether this is the use of Tetra today or broadband technology in the future, this requirement remains the same. So there is a key set of KPIs that are defined by the MCPTT communications. These KPI values are intended to ensure that LTE-based mission critical push-to-talk provides performance that is as good as existing LMR standards. So with coverage, our end users require always-on communications that is robust and reliable. The networks need to be designed or upgraded to provide a high level of inherent resilience and redundancy in the architecture. Dimensioned to provide a specific grade of service. And no network is totally resilient to external factors. Therefore, reliable off-network communications needs to be provided and remains an operational priority for the mission critical users. Speaking of that off-net, device-to-device communications, direct mode, users expect a network, direct mode network in their devices to provide communications when coverage from the network is not available. LMR solutions provide voice and data solutions as well as repeater and gateway capability within the user devices to extend communications in difficult requirements. Off-network communications typically provide 500 metres range in cluttered urban areas and up to 2 kilometres in the open spaces. These requirements are essential regardless of the technology used. So with LTE direct mode, ProSay is defined by the 3GPP and intended to provide device-to-device communications off-network. Meeting this direct requirements using LTE is not an easy task. LMR radios transmit higher power, have external antennas, and operate in UHF, VHF, and have an excellent RF propagation. None of the commercial LTE device chipset suppliers are adding ProSay support to their chipsets currently, and therefore it's clear that ProSay will not be available for the use with LTE mission critical. So the options are that we run, like the guys before have mentioned, a combined mode. Is to use an existing Tetra technology that has a proven track record of providing robust and secure off-net communications. Combining the two technologies into one device can provide higher availability of the service of the user using the best available LTE or Tetra device. Again, as mentioned previously, there's a collaborative operation alternative using a dual mode device that contains both technologies, or we can reuse an existing Tetra device that is used in a dual operation mode in cooperation with a mission critical push-to-talk device. So what makes the device mission critical? Mission critical users need to communicate without delay and with the utmost reliability, robustness, and security. And they're dependent upon these devices to provide unfettered real-time access to essential critical comms in all circumstances. Whether they're using Tetra devices today or broadband in the future, the requirement stays the same. They need to be reliable. They need to provide reliable communications, always available in all circumstances. The KPIs must be sustained, and therefore device hardware must contain the essential mission critical TCIs and other mission critical quality of service features introduced in LTE release 12 and 13. The MCX service needs to be integrated into a device to ensure audio quality, routing, priority of service, and access to bearers. Direct mode capability suitable for mission critical off-network use is also required. Levels of robustness of the radios themselves, it's required to ensure devices survive the day-to-day rigor that they're put through for mission critical users. They should have a high level of IP rating and meet ETSI and MIL specifications. However, that's usually not enough to provide satisfactory real-life performance. Products intended for mission critical and business critical users are subjected to manufacturer specific testing that stresses products well beyond their normal specs. Security is fundamental. These devices need to be secured against tampering, have software that is verified and from a trusted source, and updated with security fixes. The data residing on the device must be secured against fraudulent access, either in normal use or when the device is lost or stolen. And the least often thought about is very important in ensuring that the trusted supply and manufacturing chain. Along with that, the support, having dependable support from the device manufacturer is essential to maintain the products effectively in the field. This will include many aspects over the lifetime of the product. So it includes advice and consultancy, fast and efficient warranty and repair services, software and feature updates, and security updates. Interoperability, everything has to work together to deliver this mission critical service. So interoperability at all levels is essential to provide a vibrant and diverse ecosystem to ensure there's always something that will meet the end user's requirements and provide choice. So this complete ecosystem, as well as the considering the device itself, the ecosystem of all other components required for the device need to provide the same mission critical credentials. This must include the accessories required to operate the device, which have to endure the same environmental conditions and provide the same level of reliability and quality of service as the tools required to maintain and support the device in the field providing this critical service. So I guess coming back to the start, what does it mean to be mission critical? All elements need to work together. The networks, devices, and accessories. We have to make sure we've got the security, reliability, robustness, the coverage, performance, and interoperability, and the supply and support. So this is all required to provide always available communications. I think the key to this was mainly there's a big focus on LTE and broadband, but we really need to make sure that we keep our feet on the ground and understand the requirements of mission critical, and that this new technology moving forward has to supply at minimum what we have today. Thank you.
Colin, thanks for your presentation, and I think a very good reminder of all of the considerations that users and critical industries need to take into account as they look at their future procurements and their strategies for both their LMR networks and their passage into critical communications broadband. It's with pleasure now I'd like to introduce Simon Riesen, Senior Solutions Manager from DAN. Simon's based out of Europe, out of Denmark, and he's kindly provided this presentation, and we're pleased to have supporting this presentation locally both Marc Wood and Jeff Wood from DAN Australia. So let me hand over to Simon to tell us more about integration of LMR networks and mission critical functionality.
Hi, my name is Simon Riesen. I'm Senior Solutions Manager at DAN Cellular Systems, and today I would like to share with you some ideas how narrowband systems can be combined with mission critical services over broadband. So first, let's have a look shortly at what are actually mission critical services over broadband. The services are divided into three areas: MCPTT, MCData, and MCVideo. MCPTT actually provides more or less the same services than what narrowband systems or Tetra or DMR can do. So it includes group calls, individual calls, and also external calls. MCData also covers the same what narrowband systems can do, but in addition, due to the fact that there is a higher bandwidth available, so actually also much bigger data sets can be transmitted with mission critical services over broadband. And then we have the MCVideo. So as the name says, it is for video calls, and actually in my opinion even more important is video streaming possibilities. So if you think of a public safety and security workers, officers, if they are in the field and if they need to share information on a video to the control room, they can actually send the video from the site, or it can actually also be used, for example, to send CCTV or drone captures from somewhere towards the people in the field, so that they get the needed information. So you see, actually, MCX can do everything what narrowband can do, and actually much more. So this raises, of course, the question, so why not moving everything from narrowband to MCX? But as always in technical solutions, there are also some challenges. And let's have a look at these challenges to overcome in MCX. Direct mode is one of them, and maybe one of the most obvious ones. So that means the proximity services would provide possibility to talk from one smart device to another without using the services. This is a very common service used, for example, for firefighters. And unfortunately, on smartphones, especially due to the lower power, the reach distance is very limited. So this means also actually the use cases will be limited in this case. Then there is some shortage for private LTE if you want to use your private LTE network. But on the other hand, we can see actually in many countries there are this is moving forward very, very quickly. So I believe it's just a question of several years, and then there will be sufficient LTE or broadband frequencies available on the market. Fallback operation. So in narrowband systems, you know that if a base station loses connectivity to the rest of the network, it can actually provide the services locally in the covered area of that base station. And this isolated operation is also standardized for LTE systems, but due to the fact that the cells are very small, it actually does not really make sense. So also here the use cases are very limited, and therefore actually also the support from the mobile network operators is very limited. Similar applies also to the group addressing of the air interface. When you make a group call on a narrowband system, so a one-to-many communication, then it works in an extremely efficient way, since on the downlink the message has to be sent only once, the voice. But broadband systems, they are as such always one-to-many, one-to-one communication systems. And if you would like to use this one-to-many possibilities, it will require actually this EMBMS implementation. This is, however, hardly implemented, and the interest of the mobile network operators is very low, especially due to the fact that it's not only expensive, but it's also extremely frequency inefficient. Last but not least, I think terminal security is definitely a point you need to take into account, because if you deploy MCX services, then the users will use smart devices, and smart devices typically do not run only this MCX application, but also many other applications. So there is a certain risk for cyber attacks. So mobile device management is, of course, one way to control what is installed on these devices to minimize these risks. So now we see, so broadband is actually providing many possibilities, new services, but there are also some drawbacks. And if we now break down a little bit these different services on arguments, we could compare these narrowband and broadband systems. So voice call, I would say both systems can provide same services in a similar way, so there is no major difference. And similar applies actually also for data services, as long as the data sets are small. But as soon as you move to larger data sets that need to be transmitted, narrowband systems will not be able to provide these services. So, but on the other hand, when you look, for example, at resilience of the systems, we discussed it before, fallback mode or direct mode are functionalities that are clearly in favor of a narrowband system, and actually also guaranteed access, because a narrowband system, usually you own your network, so you can define who has access at what point of time. If you use your broadband services or from a mobile network operator, you need to actually negotiate your access to the network. Authentication and encryption, I would say it's comparable on both systems, and cybersecurity, that's just one point you definitely need to consider when using a broadband system, because a narrowband system, the terminal is dedicated to that services, so the risk for a cyber attack is, of course, much smaller in a narrowband system. Then we have, of course, always the spectrum availability. I mentioned it before for broadband, but actually, in fact, also narrowband systems, in some areas, it's not necessarily easy to get the needed frequencies for your services. So in this sense, actually, broadband has a certain advantage that you can actually build your system on existing mobile network operator services. At the end, everything ends up into the costs. So the frequencies will cost, the sites will cost, for example. Also, building up networks, a narrowband versus a broadband system is completely different. So a narrowband system consists typically of fewer sites with higher towers, where a broadband system you build in a way that you have small cells. So this depends now on the environment, which one is more efficient. And of course, you can also think of whether using MNO services, where you actually rent your services from LT, or whether you own them. So this operation maintenance, there are different ways you actually can deploy a network. And last but not least here, when you have a narrowband system, the services are actually dedicated for that network. If you build your own LTE network, of course, you can also use this data transmission capabilities also for other services. You can actually share the costs. So all in all, I would say you can these MCX services and narrowband services, best is if they work together as a hybrid network. And the next slide, let's have a short look how this can be done. So there are different ways how to do it. One common way is using a general 4-wire integration where you have just group calls and you link the groups between the two technologies. There is, of course, limited functionality. It will work only for group calls. And especially if you use donor radios, it might not be scalable. But it's a simple solution which is definitely usable in many cases. Then you can use this interworking function integration. So this is actually a standardized interface for integrating or interconnecting several MCX networks, but it can also be used to connect narrowband systems. So, of course, the whole addressing is different in MCX or Tetra, so you will need to have some address conversion that you can call between the users, but you will have definitely more services compared to the 4-wire integration above, because also individual calls will be supported in that case. But main drawback here is at the end, you still need to support 2 networks. And here comes actually the idea of having a hybrid network. So the idea here is that you have a core network, and the core network is able to route calls between the different technologies. So we have just one core, one subscriber management, one group management, and the group members can be from various technologies. But also there are challenges to overcome. For example, that if you send a multimedia message from MCX to Tetra, then this message cannot necessarily be read from Tetra subscribers. So there is some intelligence is needed to make it intuitive for all users. But let's now have a look at a few use cases. So for example, at mining industries, Tetra has been deployed widely, and also LTE networks are actually available there in most of these sites. The Tetra is used for voice services, and then the LTE networks are typically used for is it CCTV or data applications of any kind. Now, it is of course obvious that it would make sense to move at least some of these voice services towards LTE, but such a migration in a system that operates 24/7 is very challenging. So it is actually almost impossible. But if we have now this native hybrid network, we can actually one subscriber at a time, and we can also move just for those subscribers from one technology to another where it's actually needed or where there is actually additional benefit. So having a common network supporting both technology will give you the full flexibility here in that case. Another common use case here is airports or generally public safety and security. Also there, everyone knows broadband services at airports are very, very good. But on the other hand, it is also well known that Tetra is the best technology for emergency services, especially in high density areas. So, and then also when you think of the terminal types, it makes surely sense to use heavy-duty Tetra terminals for workers outside if they need it, but inside of the terminals, for example, for gate clearance, it might be more useful to have smart devices for these users. So also here, if you have one common user management, it will be very intuitive to use for the organizations. They do not need to think whether the end user terminal is using broadband or narrowband. They can be, it will be one homogeneous network with one common access to the APIs, to the PBX, and all other external interfaces. So we at DAM, we believe that hybrid networking is the way forward to integrate and also to migrate narrowband and broadband systems. So this unified core network platform will provide the easiest way to manage the network for the end user organizations, and having our native distributed architecture will also bring the highest possible resilience. And last but not least, it can actually also be downscaled up to a single site. So it is fully scalable. You can reuse the whole investments you have made in narrowband and bring these advantages to broadband. Yeah, that were some short thoughts about how to combine the technology. If you have any questions, please address them to my colleagues on site. From my side, thank you for your attention and goodbye.
Thanks to Simon for providing those insights from the perspective of an internationally and well-known brand in the communications network side. It's with pleasure now that I would like to introduce Marc Maton. Marc is with Airbus, and he's going to share some additional insights in respect to integrated solutions and applications for business critical broadband users. Over to you, Marc.
Thank you, Kevin. Thanks, Kevin. Happy to be with you guys. Let me share some idea about integrated solution and application for LMR business critical broadband users. So the first slide is just the content of my presentation. And the first slide in my presentation is just an overview of the market and now the change that we are facing. You can see like there is the PMA world, but also we are facing a new word coming, I will say like the commercial, and the commercial are crossing. Yeah, the commercial are now crossing the PMR world. So there is a new challenge in the market. The critical communication ecosystem is changing. We are facing, I will say like some example, hybrid network, MNO network, LTE network, some stuff that before on the business critical user, it wasn't happening. So now there is a big change, and we supply all the provider of PMR solution are evolving to give that to give to the end user all they need. So you can see on this slide that it's the business critical world are today many challenges. As I said, there is an explosion of data. You can see on the photo, like you think that he is like relaxing, but no, it's trying to analyze all the data that is coming to him. So this many data coming that before was just, we will say that the narrowband system was just a voice, but now we are facing like new type of solution, like we said, camera or drone, some of stuff that the command and control center will not facing before. So this is mainly the new technology and use case that we saw popping up in the market. So I will say like the most like recurrent solution that the end user is asking, it's like the CCTV camera. I said, I'm living in Singapore, there is CCTV camera everywhere. I can notice like it has to be connected to the narrowband system. It's not wanted to have like everything in the same network. Also, like another I would say case with popping everywhere is the drone. We have the commercial drone, but also the private network want to have like some drone, like some broadcasting, some video. It has to be connected. So there's new technology and use case for business critical users. So this is just like my first capital, like it's about the broadband evolution in the PMA world. So it's the first step. So you can see this is mainly where the market is moving. We are talking about hybrid. I think it's everybody know what is an hybrid network, but we are facing like the customer can't invest so much money or swap his own network. They want to a platform who can connect the Tetra network and also the commercial network. So it's like a bridge between the two network to allow the customer to have more data, secure data application on the top. So we develop on this platform, tactile management, we develop some new feature, more like we develop it for the MCX application, of course. So we are following all the 3GPP standard for MCS solution features. So you have voice, you have instant messaging, you have video services, you have localization. This is the basic, I would say, like MCS features that we are we develop in a house and we have inside our tactile management server. So on this slide, you can see like the patching between the handheld, Tetra handheld and a smartphone. So you can have communication between the handheld and the smartphone by voice, but you can see also the instant messaging and the location services. This is what we developed with the tactile management platform. So first of all, with the MCX system. So, but also we had like value added application on the top of that. So we start, as I said, we start to develop our tactile Agnet platform for the MCPTT system. But we understood that we could do way more for the customer, and we start to develop new feature according to the demand of the customer. We didn't need to make another platform. We just needed to develop it. So on the same platform, Tactile Agnet, you can find no other features like CCTV, connectivity, or external broadcast, or virtual assistant chatbots, or workflow management, and also something very important is LMR interoperability with P25 or with DMR. This is very important for the end user. And everything is open API. So our platform can be open and you can manage to develop new features. So our strategy, as you understand, on the left side, you can see that there is an evolution in the market. Whereas a midlife hybrid solution, but at the end, we would like to be Airbus, would like to be like a critical collaboration platform. So having a solution to transform like the business critical world, having like feature for the business critical world. You can imagine feature for mining, feature for airport, some stuff that the customer need now, and not just voice, but data. So this is what we develop now inside the house, some applications that we develop. I talk about 3, but we have like a lot of them. But the most important, I think, that for you, for the markets, is Agnet Workflow, Agnet Vocal Assistant, Agnet TI database. So the Agnet Workflow, it's a feature who enables the end user to make a list of tasks. So imagine you have a field user and the manager can put some list that you need to do every day. So it's very important, like this, you can track a little bit what the end user is doing and what the field user is doing, and avoid like is missing some point or is missing some task. This is a feature that we develop inside our Agnet Tactile Management and inside our Agnet application. The second feature, I mean, it's a technology feature that we all have at home. I think with, I would say Alexa on Google Nest, I think we have it. It's a Agnet Vocal Assistant. So it allows the end user to ask with a voice command some action without pushing any button. So you can imagine you avoid like when the people is in the field, it doesn't need to push, it just need to ask Agnet to call someone or to do some action. Another application, very interesting, this is EI database. So the EI database is a feature enables the field user to have access to critical information. It's connected, you can imagine there is like data server connected to our Tactile Analytics platform. So example for some user, imagine in the port, you have the field user is trying to find information about the container. He just take a picture or ask information to Agnet, and Agnet will answer him like, who is the owner of the container, what is inside the container. So he doesn't need to ask the command and control, but he just need to ask Agnet. So this is a new application that we are developing, and for each business customer, we have like connected with the servers that he needs. So because of the open API of Tactile Management platform can be connected to this type of server. And now I will talk about IoT. IoT is a surprising new technology we're facing in the market. IoT is coming. We have IoT at home also, like Google Nest or Alexa. Now you can have like IoT sensor everywhere. So it's what the customer also in the business critical world, but also mission critical world, is asking some IoT capability. As an example, IoT capability, I will say that it can save life, it saves time. I see the next slide, you will see like how it works. So this is, I mean, this is an IoT. Imagine someone in the field. You can see that someone in the field who has got like a jacket, and inside the jacket there is some sensor. So an example, imagine there is a gas leak, and this field user can notice there is a gas leak. And with the sensor they connected to the network, integrated to a network with the tactile management platform, and he can set to the command and control that there is a gas leak. So the command and control will talk to the end user, to the field user, and saying like, oh, there is a gas leak, so you need to go out. So this is before talking. So it's where like before avoiding any catastrophe, any problem in the field. So the sensors are coming, and this is an example, typically like what is happening in some oil and gas company or mining company, who can happen something like that. So this is a video now. So in this video, you can see like two scenarios. When the first scenario, it's how it works with EI features connected with the camera. So it's one of the features. And the second feature, we say like it's IoT connectivity with a sensor inside the factory or inside a mine. There is a leak, it's connected via Agnet. It can say like something happening. So for the people going out. So it was just a small video to see like two scenarios, what we are using, where we are using our tactile management and where we are using tactile Agnet. And the last, I would say the last part of my presentation, we say like a little bit about the future. I think the market is like, it's like seeing happening. I would say like, we have also a thing happening. We are thing happening this SATCOM, I would say like, the future Agnet SATCOM. So we are developing a solution where we can connect our tactile management platform and with a mobile to a LEO satellite. So imagine you are someone in the field, in the middle of nowhere, and standalone mode, it can be connected via a smartphone to a LEO satellite connected to a server and after connected to the HQ. This is one of the scenarios that we are developing now in Europe, but we are pushing also this type of solution for the business critical user. The second scenario you can imagine. So the second scenario, it's like, imagine a tactical bubble LTE. So there is a tactical bubble LTE and it needs to be connected to the HQ. So it works the same. You have the technical bubble and you can manage to have the connectivity with the LEO satellite. So the connectivity, it makes the people like far away from the HQ to be able to connect with the HQ via satellite. This is a new, and everything will be connected with our tactile management platform. So this new solution is coming. This new solution is going to be the next evolution for telecommunication now in the future. So thank you very much for this presentation. And if you have any question, I am here.
Thanks very much, Marc, for that insightful presentation. I think it's another example of a global industry supplier innovating their solutions in response to some of the functional and operational demands coming from our end users in critical communications. We did hear a little bit at the end about SATCOMs in Marc's presentation, and this will be a topic that I think is gaining momentum, is being looked at in the 3GPP standards domain, and I'm hopeful that we will bring further webinar series that cover some of the non-terrestrial network aspects that are evolving and the innovation happening there. Our next presenter is Rory Mcdonnell. Rory is Business Development Manager with Nokia, and he specialises in the transportation segment in Oceania. This is another important vertical market in our critical industries that is being addressed by industry. So Marc, sorry, Rory, I'll hand over to you to fill us in on what's happening in Future Rail Mobile.
Okay, thank you, Graham. Thanks everybody for joining the call. We've seen some fantastic presentations so far. It's good to know that we're working in such a vibrant industry. So just a quick overview from a Nokia perspective, we've deployed over 1,550 mission critical networks for our customers across enterprise, like for example, transport, energy, manufacturing, and public sector. But as Graham said, today's presentation will really focus on rail, and it will focus on future railway mobile communications. And again, Nokia has a vast experience in this space. So for example, we've rolled out over 100,000 kilometers of coverage from a GSMR perspective since the year 2000. So we show longevity and also experience. And from an IP and PLS perspective, we've helped move our customers, rail customers, from SDH, PDH, TDM networking type applications to IP and PLS. But today it's about the future. So today's presentation will focus on network convergence. So for example, next generation wireless communication, but we'll also touch on wired communication. We'll also talk about the future railway mobile communication system. So this is a standard that is being developed over in Europe at the moment, and it is expected that our Australian and New Zealand customers will align with this standard. We'll also talk about the role of 5G for FRMCS. So 5G is a key enabler for FRMCS. And as GSMR has been supported railway communication since 2000, we need to look at a new bearer, because GSMR is expected to be end of life 2030. And from a 5G perspective, we need to select a bearer that will provide the same type of longevity that GSMR did. And finally, if we have time, we can look at some of the POC activities, FRMCS POC activities, which Nokia is involved in. Okay, sorry, just a bit of a delay on the slide. So just to recap, so where are we at the moment? So from a traditional kind of communications perspective, it's quite segmented and siloed. So for example, we see, number one, we see ETCS level 2, it's rolled out over GSMR. And as I mentioned earlier, GSMR is expected to be end of life 2030. So we need a new communications bearer for ETCS level 2. We also see rollouts of CBTC over Wi-Fi at a global level. But again, does Wi-Fi really address the requirements of signaling going forward? And we'll see that CBTC now is considered under FRMCS as well. For train communication system, again, number 3, we see that train communication systems are being rolled out over Wi-Fi. And for number 4, land mobile radio using UHF. So again, voice communications rolled out over UHF. Number 5, voice and data rolled out over Tetra. So Tetra, provides very good mission critical capability, but is limited in terms of bandwidth. And also for other applications like broadband applications such as onboard CCTV. Currently, we see that in some cases CCTV is stored on board the train and downloaded when the train gets back to the depot. So it doesn't really give a lot of flexibility. So if we look at 1 to 6, what we see is siloed networking capabilities supporting the different applications. But if we move towards a converged wireless, i.e. have all those applications, examples 1 to 6 supported by LTE or 5G, then there can be, first of all, your communications will be future-proofed. Secondly, you can reduce your total cost of ownership, and then you also will simplify your communications type networking implementations within the rail environment. We already see customers moving to implement ETCS level 2 or LTE. So for example, Nokia and one of our signaling vendor customers is working with a customer in India to implement that at the moment. From a CBTC perspective, more locally, we'll see CBTC rolled out over LTE, and Nokia is also involved to implement the communications system, which will support that CBTC rollout in the future. And then we talk about train communication systems. So again, separate Wi-Fi network supporting your train communications system. But if the rail operator implements an LTE 5G network to support their signaling system, then they can actually just support their train communication system over the same network by using the QoS capability of LTE and 5G and traffic prioritization. So mentioned earlier was MCPTT. So we'll see MCPTT become more prevalent in the rail environment. And in fact, some of our rail customers are already implementing MCPTT. And key to note that MCPTT is part of MCX and is fully aligned with 3GPP standards. So now we see the implementation of 3GPP standards applications being rolled out in the rail environment, which is a massive gain from a rail perspective in terms of standardization across the board. And I mentioned Tetra earlier. So if you've already implemented an LTE or 5G network for your signaling, then you can actually run your voice applications over that and any data applications which Tetra originally supported. And finally, we talk about CCTV. So we've got MC data, which would be supported using LTE or 5G. And now, because you've implemented the LTE or 5G network, you've already addressed your broadband requirements in terms of supporting CCTV streaming from trains. And again, that's an application that we're already looking at with our customers. So key here is converged wireless networking, standardization and alignment with ETSI and 3GPP standards. So if we move on to the next slide, this is just a pictorial view of what I discussed earlier. So we want to move away from, on the right-hand side, we want to move away from multiple siloed networks to like a future unified converged network. So we want to implement applications such as automatic train operation, passenger information systems, smart stations, smart rail maintenance, management support systems, and smart infrastructure. So as you can see here, if the rail operator implements a converged network, it will result in increased efficiency because you can actually design your LTE and 5G networks in the future to support availability up to 5, 6, or even 7 nines if required. On the top of the slide here, we see we've got a train coming through a tunnel, so it shows the train on the wayside. And just to recap, if we implement an LTE 5G network, we can support the CBTC and ETCS signaling applications. We can also take data from the train, i.e. support rolling stock condition monitoring, and also on board the train itself, we can support operational staff. And if the rail operator wish to do it as well, they can also support passenger connectivity, i.e. Wi-Fi on board via the private LTE or 5G network. If we look at the tunnel as well, we've got track maintenance staff there, bottom right of the tunnel. So again, the track maintenance staff can be connected to the private LTE 5G network implemented by the rail operator. But then also I mentioned there's a wired component as well. So since 2006, Nokia has been moving our customers away from SDH, PDH type applications, TDM applications to IP/MPLS networking, which is like the solution of choice for wired connectivity in the rail environment. So this is like where we've got fixed devices such as CCTV, fire alarm, general alarm, public address, and emergency trackside telephones. So your IP/MPLS will provide the mission critical type capability that is required to connect these devices. If we look at move towards the bottom left of the slide, we look at the smart station and train depots. And again, implement an IP/MPLS network or 5G network in your rail environment, and you will address all the connectivity requirements for your stations and your train depots. So for example, connectivity for video analytics, public address, passenger information, CCTV, and even applications such as passenger counting. We also see the adoption of private networks within the rail depot environment. So it's a highly metallized environment, so not really suitable in terms of Wi-Fi coverage. Also, the environment changes as the train moves around, so that plays havoc with Wi-Fi connectivity as well. And then finally, we can see IoT and sensor fusion. So with the implementation of a 5G LTE network, you can implement a myriad of IoT devices within your rail environment. Okay, let's touch on spectrum. So in Europe, what we see for GSMR, it's 4 meg. Now basically we really move into FRMCS. So in terms of spectrum, FRMCS in Europe, GSMR currently 4 meg within the 800 to 900 band. But from a standards perspective, FRMCS likely to be 5G, could be LTE, will be implemented at 1900 at TDD. So 10 meg has been reserved for railway applications in terms of FRMCS. Within rural and remote areas of Europe, it's quite similar. Most likely they'll go for option B here. So that's 10 megs, 1900 for FRMCS. So when I say FRMCS, future railway mobile communications, likely to be 5G as the key bearer there. And then we move to capital cities within Australia. So as we know, 1800 meg, 15 megahertz has been reserved within the 1800 band to support critical voice communications, ETCS level 2. This spectrum could be reused if necessary. So for example, you could allocate 5 meg towards existing GSMR applications, and then reserve the other 10 meg for FRMCS type applications. But we know that ACMA and the rail industry as a whole in Australia are looking to secure spectrum within the 1900 band. The advantage of this is that the Australia railway community could benefit from all the benefits which will be generated from the standardization that's happening over in Europe, i.e. a device ecosystem and an ecosystem of suppliers and standards as well. And now we look at future railway mobile communications. So what are the key drivers? So there's a demand for broadband, so increased efficiency. We look at improved customer experience and automation within the railway environment. So all drivers optimize. Then we look at optimization of networks. So as I touched on earlier, collapse all your networks into one converged wireless or wired network. So you reduce your complexity and then you increase your flexibility. And finally, FRMCS really will address the long-term support for the signaling system. So European Train Control System Level 2 and communication-based train control for the next decades. So again, we really need a replacement for GSMR. In terms of requirements, we look at critical communications. So we look at voice, including group calls. So that would be supported by MCX, so MCPTT. And as mentioned earlier, we're already implementing that for our rail customers locally and at a global level. We'll also support train control ATO, automatic train operation and train location using FRMCS. Again, more likely to be 5G as the chosen bearer. And then machine-to-machine and telemetry for critical applications. We also got to consider performance communications. So if the railway operator has a 5G enabled FRMCS network, they can also enhance their efficiency and punctuality of the system. So for example, implement machine-to-machine telemetry to improve journey times and also implement sensors within the rail environment and also reduce maintenance costs. So go for predictive maintenance rather than scheduled maintenance. And then because we've got broadband capability, you can implement CCTV, passenger information, and all the other applications as touched on earlier. From a FRMCS perspective, the timelines are concepts began to be developed pre-2015. We saw standards and realization being developed post 2016. And those standards will be finalized 2022/2023. So again, the Australian rail community can really benefit from the standardization that is being developed in Europe. To support the implementation of FRMCS, we'll see the POCs and trials and pilots being rolled out pre-2025. Nokia are already involved in a number of trials. So for example, the implementation of 5G to support automatic train operation with our Deutsche Bahn in Germany. And also we're looking at frequency testing with Swiss Rail in Switzerland. So that's basically where you implement a 1900 solution on the existing GSMR infrastructure to make sure that the tower infrastructure will support FRMCS in the future. So that is actually very successful. And then we're also involved in a 6-year R&D trial with, again, with Deutsche Bahn in Germany, where we've implemented a 5G network to support MCPTT applications and signaling applications. So in terms of 5G, what does it deliver? So it delivers extreme mobile broadband greater than 10 gig, so much better than what we see currently within the rail environment. And then it will also support critical machine communication. So it delivers ultra reliability and low latency. So this is key for automatic running of trains. And then finally, machine-to-machine communication. So we'll basically have the bandwidth capability to support everything, all applications. What's key in this diagram is that the FRMCS, you're looking at a multi-access core. And we can see here that satellite, 4G, 5G, Wi-Fi, and fixed is supported at a core level from an FRMCS perspective. But it is key to look at mission critical capability. So 4G and 5G will deliver the mission criticality required to deliver mission critical applications. Satellite Wi-Fi can support other applications which will augment the rail operators' deployment of the communications network. And here we can see that the multi-access core is ETSI standard and 3GPP standards based. And as you can see in that diagram as well, just adjacent to the multi-core, we've got mission critical communications there. So all ETSI and 3GPP standardized. If we look at the left of the diagram, we look at the railway applications themselves, such as the ETCS level 2 and the CBTC and the train control. So these are all railway specific standards. But key here is that the communications network has now been decoupled from the railway environment. So previously GSMR was a railway-based standard communications system. And now we look at 5G LTE, it is ETSI and 3GPP standard. So we will see more competition in this space, a greater vendor environment. So that's it from myself. That's my 15 minutes. But once the slides are shared, I have provided additional slides which provide further detail on what Nokia's involvement in the FRMCS POCs at a global level. So over to you, Graham. Thank you.
Thanks very much, Rory. I think that was a really good overview of the direction that rail communications is heading and the progress that's being made. I'd like to reinforce what Rory's been saying. The Union of International Rail Union for Communications, 3GPP, the ETSI community and the European Union have all come together to, one, make sure that the standards will support rail functionality. We're now seeing multiple rounds of plug tests going on with real life equipment. We're probably into our fourth testing of some of that FRMCS capability in the next plug tests that will be proceeding in November of this year, having come off a remote testing that happened earlier in May. So I think good progress is being made for the rail vertical market, which is still well catered for by some of the existing narrowband technologies and some of the 4G solutions that are emerging and actually being deployed in real life situations around the world. So confidence this technology will be drawn through in a 3GPP ETSI compliant fashion. And the industry is working hard, as Rory's just pointed out, to make this a reality, given the end of life that we're seeing with many of the systems based around GSMR. So thanks again, Rory, for that. And, it's with pleasure now that I would like to introduce Alan Seery from acquirer here in Australia, and he will give us some insights on the work they've been doing in respect to private LTE networks. Over to you, Alan.
Thanks, Kevin, and welcome home. So the first generation of 4G LTE networks delivered broadband services only, like we said earlier, but now adding voice and sensors and MCPTT is pretty straightforward. So we've seen significant maturity in the end-to-end ecosystem over the past few years. There are now many sensors working on 4G and 5G. We've seen the evolution of fit-for-purpose handsets that have been developed for use with emergency services and in harsh environments. We've seen some great examples of this already from the earlier presenters. We now have a proven track record of supporting automation and autonomous operations, which has been demonstrated now for almost a decade. So with 4G and 5G, we have a single network layer where data classes can be truly defined with an end-to-end quality of service and encryption over the air, which delivers reliable, predictable, and secure communications over a licensed frequency. Back in the early days of private LTE, the first network core occupied 3 fully populated 42 RU racks, but now we see a single RU server can suffice, and furthermore, now we're seeing developments where it can be hardware independent. We're now seeing an era where 4G and 5G core network environment moving from sizable hardware tied to network cores, it's now being software driven and able to run in an appropriately resourced container. At Acura, we have a trailer containing a complete 4G network, which is a core and RAN, which is deployed into the field with a software-enabled core that runs on a microserver. We've configured it from scratch to the client's specifications and delivered it on site and commissioned within about 2 weeks. This used to be a 2 to 3 month exercise. RAN elements have now been broken down into smaller discrete elements with standards-based interfaces. This is great for carriers as it opens up choice and creates market tensions between equipment suppliers. For enterprise or private users, I'd advise that you proceed with caution if considering heading down this path. Introducing complexity into a solution to provide choice may leave you stranded with an orphan solution without end-to-end support and no single entity to resolve issues. While you may be able to choose best of breed in all elements, my question is, who do you call when there's a fault? My personal recommended approach would be to choose a single vendor for your end-to-end radio access network, or partner with a system integrator who will offer service level agreements on their recommended solution. The analogy being, swapping out the engine in your car for a higher performance model. You will have to take on all the risk for performance and reliability and leave yourself vulnerable to only having specialty skill sets being able to service your unique vehicle. For carriers, this is not an issue, as they have the resources to support this approach, and if they land on a solution, it will be repeated many times and therefore easier to support. For enterprise, it's all about accountability and supportability. It's not just about choosing what appears to be the best technology. With a mature and coordinated whole of business strategic approach, the end user could consider converging all wireless existing applications onto a single network. And we've seen many people refer to that today. This network can support one-to-one voice. It can support one-to-many, that's push-to-talk, MCPTT, and all applications are designed with the appropriate end-to-end quality of service. And now with fit-for-purpose handsets and end devices. You then have all your typical broadband applications that we've seen, supporting autonomous operations, dispatch, location awareness, and many more. And now with 5G, we're seeing many move to remote control as well, with the low latency offered with 5G. Also, you can now have a plethora of sensors on the same network as well. We've seen some of our users have thousands of sensors deployed across plants where they used to have to wire them up hardware, or they used to have to hardwire them previously. For this to become a reality, we have a view that it takes a business-wide vision to take comms to the maturity where it can be consumed as a utility. So do you guys have a whole of business strategy for industrial communications? Those that do now understand that when you deliver a business-wide solution, that the communication networks are no longer the weakest link in the supply chain, and this will quickly highlight where the next focus areas are located. 4G can do all of this, and the 5G ecosystem is emerging fast. And for those whose operations are locked in areas where spectrum access can be challenging, you now also have options. You can work with a system integrator that is affiliated with a carrier, or you can wait for 5G spectrum for enterprise that will be released in Q3 next year. The vendor ecosystem for platform choice has grown significantly. The end user is no longer limited by hardware. The market used to be dominated by the major telecommunications networks providers. It's comparable to the early days of the PABX, which was then hardware focused and on-premise. Now we've seen a shift to as-a-service solutions, software-based solutions, or cloud-based telephony. The end user just needs to have a device to interface. The value adds are now so much easier to activate. Most are software enabled, not like the old days where the equivalent of a line card may be needed to activate a feature. Software-driven platforms also can start small, which makes them cost effective, and then they can scale significantly with less overhead. So you can license up as you need to. This now makes commercial models available to acquire the technology on a per device or per application or as a service basis. There's a long list of vendors queuing up to join the race for 5G global domination. We now have Amazon, Google, Microsoft, and many others. All of these guys have 5G as a service offerings coming to market. And to be honest, it all works well until it doesn't. And then who do you call? So as networks become loaded with traffic, then management becomes more and more complex. Do you have the right in-house skill sets to support such a network? And is your connection between maybe the cloud and your operations areas robust and resilient enough to support business or production critical applications? These are the choices that you will have to make if you're considering heading down this path. But having the right support is key for when you have issues. For us, it's all about spectrum. Radio spectrum here in Australia is licensed by ACMA. This is one of LTE's greatest benefits for both 4G and for 5G, as you get access to clean air, but it also requires effort to secure it. Gaining access to spectrum in regional and urban areas is getting easier than it was in the past, particularly now with ACMA planning to release spectrum for 5G. Over the past few years, ACMA has been engaged with industry to recognize the requirements and to offer greater flexibility in the use of spectrum to support Industry 4.0 use cases. And many models for delivering services that you may need are emerging, from guaranteed capacity on a public network to sharing infrastructure with a carrier, with some shared and some dedicated, and then all the way through to fully private. The choice is yours and will depend on the criticality of the applications that you are trying to support. So the future is promising, but it can get out of control pretty quickly if you don't have a whole of business plan and the right support model in place. Order can be restored to deliver on the promise of advanced wireless broadband by working with trusted partners who'll be able to work with you to identify the best match technology to your needs and use cases. And back to you, Kevin.
Alan, thanks very much for those insights. Coming from an organisation that's had some practical experience in this area, I think the issues around spectrum access, the highlighting you've given of the vibrant supplier base that is growing every day, but also the cautions about ensuring whatever strategy you may look at for deploying private networks, that you evaluate your internal skill sets versus those of the supply network and integrator. So some really important points you made there, Alan, for those that might be contemplating private LTE. deployments. So it's with pleasure now that I would like to introduce Gary Botley from Zetron. Control rooms, command and control centers are a really important part of the ecosystem. And as Gary will no doubt highlight, an important part of the integration of band and broadband networks and the delivery of functionality to the end users. Over to you, Gary.
Thanks, Kevin. Yeah, good afternoon, everybody. And I noticed through the presentation so far, there's a common theme that appears around hybrid technologies, MCX, interoperability, and all those things, which is great because all that culminates in the control room at some point for a lot of our mission critical customers, whether they be public safety or in the transport sector, rail, airlines, airports, ports, or even in some of the larger utilities, mining and resources type applications. So we'll spend a few minutes talking about, we've only got 15 minutes, so it's hard to cover everything, but we'll talk about what's happening in control rooms, where we are today, where we're heading in the future, and what some of the important considerations could be. Okay, my screen's not advancing either. There we go. So control rooms today, as we're probably all quite familiar, mainly voice-based. So things like radio systems, whether they be digital, analog, digital in whatever format they may be, P25, DMR, Tetra, etc. With some, more recently, some PDT over cellular type applications like ESChat or Tasta, those sorts of things, and also voice coming in via telephony, SIP trunks, or in the past by ISDN or QSIG, whether they be straight old POT services and ring downs. So that's all where we've been, where we currently are today, and integration with third-party solutions is part of the control room today, whether it be location services, logging recorders, mapping, part of location service, I guess, video management, and so on. So it's all pretty easy. That's pretty much out of the box in most of the time. So obviously control room integration continues to evolve. So as I can't remember who mentioned it, somebody mentioned a lot more inputs are now coming into the control room. Things like vehicle telematics, Internet of Things, social media. A lot of the times we're seeing now, we hear from our emergency services where people report issues, fires or whatever on Facebook before they bother to ring 000. So it's important that emergency centres are across those types of feeds in some way. And of course, while the emergency services are out there now, they're wearing body-worn devices. And we've got a lot of things happening with drones as that continues to evolve. All of those inputs have to come back to the control room at some point. Yes, as we've just said, there's much more inputs coming in than just voice. Mobile devices, the Internet of Things has been mentioned, social media, location services, and other technologies are all mainstream. There's more information to assimilate in the control room than there ever has been. So the control room essentially becomes the focal point. So brings all those inputs together that we spoke of. Oops, that jumped past. To the next one. So the challenge, how do we provide the dispatcher or the operator with useful information? It's all very well, all the massive data coming into the control room. The challenge is, how do we filter it and massage it to be in a usable form for the operator? And that's where the development and the future of control room design is taking place, so that we can enable operators to take predictive decisions, to take action. So it might be like a geofence breach, or it could be analysing situational awareness data and the whole pile of stuff. And I guess a lot of that probably hasn't even been thought about yet in how to present it to the operator. And again, it'll all become, from a Zetron point of view, I guess the development will evolve based on customer demand and trends around the globe. A few other things that probably are very important to consider in the control room is open standards. So products that utilize open standards obviously can interoperate. That doesn't mean just at the control room, it sort of means out in the field as well. As we probably all know, proprietary solutions typically do not support a great deal of interoperability. And with open standards, you get the freedom to choose equipment that meets your customers' needs or their customers' needs. Sometimes proprietary solutions can limit that to a single vendor's products, and obviously ability to select equipment that fits a budget. We've all talked about MCX in their presentations today, which is great because obviously that's where we're all heading. For Zetron, that is simply, it's not a simple thing at all, but it's another interface, same as P2E5 CSSI is, same as a DMR AIS interface is, and MCX is another interface. So that'll take the form of MCPTT. It'll also be mission critical video and mission critical data that will appear in the control room console system. And again, we mentioned open standards. Zetron's developing to the 3GPP standards. Currently release 16 is what we're developing to. We have that currently in active development at the moment. And there'll be, I guess, a combination out there in customers, whether they be private networks, like in some of the rail things that are happening at the moment, or there could be carrier networks too. And as we all know, FirstNet, ESN, and their local PSMB are examples of those things. And of course, in an MCX network, there's a whole pile of new features that you just don't get with LMR. Some of the things that we've probably just spoken about in the last couple of slides also. Other considerations, there's been a lot of impact on control rooms due to COVID. So we've seen a lot of customers or a lot of control rooms setting up pop-up control rooms, for want of a better word, where they've chosen another location and relocated some operators to there. Fortunately, in the world of IP, that's all very easy. Just as long as you've got robust WAN connectivity back to the system core, you can put your consoles and set up a pop-up control room wherever you like. And I guess the reason they've done that is to try and spread operators across different locations to reduce exposure if COVID should get into a particular control room center. So as you can imagine, in most mission critical control rooms, you don't want your control room having nobody in it. Cybersecurity, that's another somebody mentioned that earlier too, continue evolving topic. It's becoming quite complex as we all know, and it's a constant and significant threat to all our customers. And of course, now there's legislated the Essential 8 maturity levels, which for those that haven't seen that is things like airlines and public safety. It's mandated that they follow the Essential 8 legislation, which talks about different maturity levels of cybersecurity. And it rates them on a scale of 0 to 2. So it gives a bit of a matrix of how to evolve, which is great, rather than mandating you need to be at a certain level. So things like obviously antivirus, patching, software releases, operating system updates, change deployment, event logging, disaster recovery, encryption, firewalls, passwords, internet access, remote access are all part of that cybersecurity considerations, amongst other things. And that was pretty much what I had for you guys. I hope that was of interest, and thank you very much for joining us.
Gary, thank you for your presentation. There's a lot of considerations around control rooms, and you know, expert advice from companies like Zetron and others is well worth taking. It's with pleasure now that I introduce James Pickens, Chief Digital and Technology Officer from the New South Wales Telco Authority. We're very pleased to have Telco Authority as a TCCA member, and I think underscores the collaboration that is going on across the globe between government authorities that are responsible for delivering not just the existing land mobile radio capability, but charting a course towards critical broadband. So over to you, James, to give us a view on what's happening in New South Wales and across Australia.
Thanks very much, Kevin, and really appreciate the opportunity to talk to you guys today. So as you mentioned, I am the newly appointed Chief Digital and Technology Officer at New South Wales Telco. Just started last month, and it's been a great journey so far. I'm going to play a video very shortly, and this video talks about the role that Digital New South Wales, of which the Telco Authority is a part, talks about what the role we play in Digital New South Wales, and of course the critical role played by the emergency services It focuses on the flooding events that happened through northern New South Wales earlier this year. So I'm just going to move forward to that now, and then I'm going to go through and give an update on our PSN network and what we're doing in terms of our other critical build programs, and we'll go from there.
In early 2022, New South Wales was devastated by the worst floods in recent history, with water levels rising to historic levels. Digital New South Wales is supporting New South Wales communities to respond and recover using a range of technology and services. During times of crisis, when every second counts, the Telco Authority's Public Safety Network provides an interoperable radio system for emergency services. It is the most critical communications network other than 000. The Telecommunications Operations Centre coordinates with emergency services and carriers to develop geospatial maps and situational analysis using the newly developed Joint Intelligence Management System. The system provides real-time monitoring of risks to help protect telecommunications infrastructure and help keep frontline responders and communities connected. The Spatial Operations team continues to fly over the flood extent across northern New South Wales, producing response flood imagery. We are supporting New South Wales Public Works and the State Emergency Service by accurately mapping the peak water level of the floods around impacted areas. This helps us provide advice to the State Emergency Operations Centre on priorities for the community. Through the work of the Telco Authority and Spatial Services, Digital New South Wales continues to lead the sector in the development of data-driven analysis and communication services to support New South Wales. Into the future, these important services will help us prepare for and respond to future incidents, so we can keep the community safe.
So what you see there is a huge amount of work that goes into managing these events when they strike. You know, they are significant and they have a huge impact on local communities. So what this also highlights is that our role within Telco New South Wales under the State Emergency Rescue and Management Act is to work with the emergency services and provide that critical comms piece and protecting the infrastructure that supports both customers in the community and, of course, the emergency services. Colin mentioned a little while ago in his presentation about what is mission critical. You know, and our PSN network is absolutely right there in terms of that criticality. I'll talk a little bit more about PSN specifically in a minute. This slide here talks about the role that we play within our operations centre, and particularly in our telecommunications emergency management unit, in terms of coordinating the effort between emergency services and in some cases other carriers as well. So one of our mandates is to work with carriers and emergency services to protect all assets. Connectivity is of critical importance now, getting more and more important every day. And by working with the carriers and with emergency services on the ground when these events take place, with coordinating efforts, we can protect as much infrastructure as possible. So the PSN itself, so outside of the 000 capability, the PSN that we have today is the second biggest, most critical telecommunications service that exists in New South Wales. So like many of the other presenters today, you know, it's using a P25 radio technology, and how it operates and the criticality that it operates with, the resilience that it must have is right up there. So operators often talk about 99.9% availability, etc. But what's really important for us and where we really focus in building our resilience for backhaul and for power especially, is that we have availability when it counts. You know, it's all well and good having availability for 51 weeks of the year, but if something goes wrong, if we need to get people on the ground, we need to have a public safety network that people can rely on. And that's where we're building towards at the moment. One of our programs, which I'll talk about shortly in another slide, CCEP, is building out the PSN to even greater coverage dimensions. Right now, we're sitting at around about 44% of the landmass of New South Wales covered, and it's around about 97% of the population. But part of our focus area, or our focus areas, as you can see there, so we do service delivery, We're also involved very heavily in the spectrum management on behalf of New South Wales Government. And we're doing that coordination effort, as I mentioned before, from our team of the Telecommunications Emergency Management Unit, as well as running a number of major build programs as well. So our critical programs, so critical communications and enhancement, which I'll talk a little bit more in a dedicated slide very shortly, and connecting country communities. This program is about building digital capability in communities that are poorly served currently. So we've done a number of works, for example, through Kangaroo Valley and the Monaro region, where we're building out a capability there by improving building towers, improving radio access, improving fibre presence, and trying to lift the experience for people in those areas. For example, targeting 25 down, 5 up in terms of throughput capabilities in the short term, and working towards 50-10 in a couple of years as well. So there's a number of initiatives going on in that space. PSMB, New South Wales Telco is taking a very front seat role as it relates to PSMB. We've talked in a lot of the presentations today about the ever increasing volume of use cases. So our feedback that we receive from emergency services organisations and others is really demanding a greater level of capability. The requests of data are increasing. The number of things that emergency services organisations need to do and want to do while they're out there in the field is increasing. So we firmly believe that having a strong, capable public safety mobile broadband capability is going to be at the heart of what we need for Australia. And New South Wales Telco is deeply involved in leading a couple of the work streams associated with that. And finally, the Mobile Black Spot program. Again, there's been a lot of coverage about this in the media. So Mobile Black Spots is building out coverage capability, focusing on transport and rail corridors and pockets of isolation that are poorly served by existing radio coverage. So just to talk specifically about, excuse me, just talk specifically about CCEP, so our Critical Communications Enablement Program. So this is a government-funded $1.4 billion initiative to really shift the dial, to really lift the coverage and capability of the PSN network. Prior to CCEP kicking off, we were at around about 32% coverage of the state landmass and less than 80% population, which is obviously not enough, not good enough for what we need from a PSN perspective, a critical comms perspective. Right now, as of today, in fact, just last week, we announced our 250th site being completed as part of that program. And we're now sitting at the 44% that I mentioned in our previous slide. The ambition and where we will get to is to be able to cover 85% of the geography of the state and cover a huge 99.7% of the population. We saw specifically recently, going back to my video example of Northern New South Wales, we saw what this meant in that region. And since 2017, we've delivered 115 new or upgraded sites in that region specifically, meaning that during this terrible event, we did have over 90% landmass coverage and 99% of the population covered as well. So the PSN network, despite there being power and power problems and issues for some of the other carriers, the PSN was there and it was reliable and the emergency services were able to use it. So I think it's a great example of investment in critical communications and something that we need to focus on going forward as we move into PSMB. I think that's it for me, Kevin. It's back to you.
Thanks, James, for that. It's great to see some of the leadership that's being shown in New South Wales, and likewise across the world. We continue to see public safety networks reinforced, expanded as those agencies chart a course for complementing with broadband services. So really looking forward to the next 12 months, public safety mobile broadband in Australia. It's with pleasure now that I introduce Neal Richardson from New Zealand. Neal's been intimately involved in the progress that has been made over a number of years now in upgrading and unifying the capability for public safety agencies across New Zealand. So I'll hand over to you, Neal, and you can let us know what's been happening.
Thank you very much, Kevin. And I don't know where the last 2 hours have gone, but the amount of material and the development in this industry is just amazing that we've seen over the last seven presenters, and I feel quite honoured to be part of this process where we are sort of explaining where New Zealand is at with where we are with our program. One moment, thank you. So New Zealand's in a slightly different place from New South Wales Telco Authority. It was not many years ago, although some would say it was a very long time ago, that the different agencies around New Zealand realised that their communications and their critical communications capability was getting a little old, and the cost to do that independently was just not going to be viable for most of them, if not all of them. So the next generation critical communications lead entity was established, and that was kind of formalized in about 2017, 2018 through an RFI process that went to market, and I'll touch on that in a second. But the key with NGCC is it's structured a little bit different from what I've seen in other parts of the world. And just touching on something that Kevin said earlier, we've been part of the TCCA for a couple of years now. And the benefit we've got out of that is just, it's immeasurable. The ability for us to communicate and talk with entities around the world, just talking about where they're at and where they're going and how they're doing it, has enabled us to structure and have a lot clearer view on what we're trying to do for the New Zealand Emergency Services. And what we've done is with the NGCC lead entity is we've established an organisation that is led by the agencies. We have a governance structure that involves the chief executives and commissioners, etc., of our police, fire and emergency and ambulance organisations, and they are part of the governance board, and that governance board reports directly to ministers of the government. So we have this direct path for driving forward the needs of the emergency services in New Zealand. And the critical communications capability is where NGCC sits right now. We're focused solely on trying to provide reliable, secure communications for that sector of New Zealand. I'll just touch on really a bit of a journey that we've been through. So my particular background is 30 odd, maybe more than 30 years of telco experience, and the last 20 has been in the design of cellular networks. So I was quite excited to come on board just over 3 years ago on a program that was looking at a cellular-centric capability for emergency services. And that's what we went to the New Zealand government with. We identified, we thought that would cost through a business case process, with cellular being the prime capability, with LMR and paging and satellite supporting cellular as the key going forward. We went through a requirements process with our agencies, and I can't speak enough about how working directly with the agencies and having the agencies develop together the requirements for the market process really gave us a great foundation that we were able to go to market with very clear requirements for the market. What came back was not necessarily unsurprising, but it meant we had to change our tact, and we realized that the maturity that we were looking for from a cellular centric view just wasn't there for us. So we had to reassess that, where critical communications and the reliability of critical communications needed to sit in the emergency services and public safety sector. So that was when we got to last September. We've now gone through a process of identifying vendors, identifying solutions, and we're so excited that this week, the New Zealand government is discussing where our budgeting will be for the next 10, 15 years. But what led us to a conclusion through our RFP and market process was that digital LMR, it has the most strongest place in that, what we call a network of last resort. When push comes to shove, as was said earlier on by more than one of the previous speakers, cellular doesn't have that isolated operations, that device-to-device communication capability. So the digital LMR really needs to be a foundation capability that we provide to our emergency services. Now, that's not to diminish the absolute growth and need for cellular capability. And it's a little bit like, I use the analogy with people who try and tell me that one replaces the other. That's a little bit like someone coming into my shed at home and asking me to replace my saw with a hammer, right? They're two different tools and they do two different things. And the LTE in the broadband world is just growing and growing. The ability to get information in the hands where possible of emergency services is something that emergency services, just like James said, are turning around saying, we must have, we must have, we must have. So this is where we're leading to with our solutions going forward. We're still looking at telepaging. Yes, I'm old enough to know when I had a telepager in my pocket when I was in call out, but it's still a key thing from a coverage perspective and a reliability. Cellular is the growth area, but digital LMR is going to be here for quite some time because it just can't beat the capability that it provides emergency services. When it comes to sort of scope, there's obviously some key things that we need out of each of our three technology pillars that we're focusing on now. That's not to say that we won't be focusing on other technologies in the medium and long term, but these are the three technology towers that we're delivering through to emergency services over the next couple of years. The digital LMR, like I said, foundational capability, just got to be there, reliable, resilient, but also moving to a digital environment. So we have pockets of P25 phase 1 for one of the agencies today that we support. But the rest of the agencies are all on analog networks and aging analog networks, as I say. So we're building out as part of this program, and it's also called Public Safety Network. That seems to be quite common around the world. Is a digital LMR network based on P25 phase 2, which gives us a whole lot of security and a whole lot of new features that just don't exist in the analog world. We're still going to carry on, like I said, with our personal learning. There are remote parts of New Zealand where cellular and or LMR just don't reach, that we're able to get paging services into so that we can call out those volunteers and critical personnel in those emergencies to turn up to fire stations, turn up to incidents when we need them. So we're still going to go forward with a personal learning capability. And then, of course, there's the cellular broadband, as we've talked about, and all the way through these other presentations. We're doing a slightly different rollout for New Zealand. We've got the opportunity to work with the two major carriers in New Zealand. We're going to have the ability to utilise both the coverage of both of the networks through roaming capability. And then we're also having the ability to prioritise all of our data services above the general consumer traffic across the networks. And so that's something we're just finalising through the contract process at the moment. The ability to prioritise the emergency services data traffic off their smartphones, routers, tablets, laptops, etc., is absolutely critical, especially when there are congestion scenarios in the cellular world. And we all know that in a perfectly operating environment, you don't need priority, you don't need preemption. But when it comes to something that's happening, whether it's a large car accident on a large motorway, a sporting event at a sports arena, or just a fire in a rural environment, there is always going to be lots of cellular traffic in the background And the agreement we're working through is to ensure that our emergency services do get the prioritisation they need on those cellular networks so that they can do their jobs. And if necessary, with the ability to preempt other users off that network so that the emergency services do continue on getting the communications they need. Like I said, the whole idea of the cellular is we know it's the growth area, and we're just trying to set ourselves up so that organisations can just get more and more connectivity and information that turns into insight, that turns into action at the front line. Just a little bit on the timeline. We're in the like I said, we're really excited this week. We're hoping to hear from the New Zealand government about funding, and all that being equal, we should be heading towards an LMR or digital LMR environment where, towards the middle to third quarter of next year, we're starting to pilot our first, and roll out our first regions for the LMR build. At the same time, earlier in the year, we should start getting the first drops of capability for our cellular delivery plan. Roaming's probably the first one there. We've got a great solution in front of us where the telcos are going to provide us with real-time visibility of their network status that we can roll out to all the control rooms and other appropriate agency representatives. So that can help in situational awareness, understanding if there's an incident happening that's large scale, the operators and the dispatchers can understand whether there is likely to be cellular coverage there, or if there's another outage. When you have national disasters, whether they're floods or other types of earthquakes, is a big one in New Zealand. Cellular capability and all network capability can fail at some point, and the idea with what we're getting from our cellular providers is that real-time visibility of the status of their networks, so that we can then appropriately task the people who need to go out to those places with the right tools. We've got a lot of work to do, working side by side with the agencies throughout the acceptance process and the deployment process and transition of all these services. But it's quite an exciting time, and I can't wait to get started. I've enjoyed the process we've gone through to date, working with the engineers, with agencies, developing requirements, going to market, working with the different organisations that have responded. But now we're getting into the cool stuff, which is starting to build and deliver. So I'm really looking forward to that. That's just a quick summary of what's happening in New Zealand. I appreciate the time. Thank you, Kevin, and everybody involved, and thank you. Have a good day.
Look, thank you, Neal, for your update, and best wishes for a successful budget outcome. I think New Zealand is a really good example of how they've drawn together the agencies that they've set up, the appropriate governance vehicle to have oversight of these initiatives, and they've progressed through to the point now where, budget willing, they will be able to start the implementation of these important services, and importantly, getting unified networks that bring those agencies together on platforms. And again, I think what's really important to our global critical communications stakeholders is we have end users like New Zealand government, like Australia Telco Authority, joining in with their peers who are members of the TCCA and helping industry understand what are the priorities of the end users. Where should we collectively be concentrating our efforts in the standards development, in the implementation and commercialization of solutions that help these organisations overlay critical broadband on top of their existing LMR networks and allow some of the interconnection of all of that functionality in a form that is usable for their end users in their control centres and so on. So I really congratulate both agencies in Australia and New Zealand for the collaboration that they've been facilitating with their peers overseas, which is also helpful in us ensuring that innovative solutions will meet these end user needs. That brings us to the end of our presentation session. You have a minute or so to add any questions you might like into the question and answer session. While I'll advance one more slide just to let you know some of the initiatives coming up that you may be interested in. So please type any questions you have into the Q&A section. We're really pleased to bring to everyone's attention again the major event in our region being held in Melbourne, the Comms Connect Melbourne event, which is happening on the 18th to 20th of October. The 18th will be a series of workshops, masterclasses, while the 19th and 20th will be the main conference program and a great lineup of international and local speakers. We're really pleased to have the agencies from New Zealand contributing to those. We have representatives from the US and other international regions coming in to share their insights, and a great lineup of both local and international organisations that are bringing innovative solutions to market. So please take a look at the links that are given below that left-hand part of the slide. We just completed a very successful Critical Communications World event in Vienna in the last week of June. And we were really pleased that we had around 20 government authorities from around the world come into a global village that we set up. And that was a centerpiece for both the collaboration between those government entities and with industry. We've scheduled next year's Critical Communications World to be in Helsinki in Finland, 23rd to 25th of May. Take a look at the links there and you'll get some of the advanced information. And I really, really recommend to anyone in this industry the investment of 2 or 3 days at either or both of these events is really well worthwhile. And it's the place where we bring the entire industry together. So with those couple of promotions, I'd like to move across to the few remaining questions that we have sent in from the audience. And thank you again for everyone who's registered and joined us today. I'd like to direct the first question to Rory, if I may, and this is to do the question around, in Europe, 1900 megahertz has already been set aside for FRMCS by any countries. UK was always using 1900 meg for different purposes. Could you make any comments around this, Rory?
Yeah, so other than 1900 has been set aside from a European perspective, and 10 meg within the 1900 band. So we will see an ecosystem of devices being developed. So, for example, there's a project over in Europe where the signaling vendors, the communications vendors, and the standards bodies have all come together. So it's a 5G rail project, and they're all working together collaboratively to develop their solutions. And also it's in a lab environment. It also relates to field trials as well. And the outcome of that will be the testing of the FRMCS standards and the development of a complete ecosystem to support the FRMCS within the 1900 band. And as I mentioned earlier, from an Australian perspective, 15 meg within the 1800 band has already been allocated and rail operators are currently using that. There is a discussion going on as to whether ACMA will allocate 900, I think it's 10 meg within the 900 band. for rail operations. And in terms of New Zealand, they're probably looking to, well, they are actually looking to align with Europe as well in terms of reuse of the 1900 band.
Yeah, thanks, Rory. I think it's another great example of the collaboration going on across our critical industries. I mean, I've seen firsthand the work that's gone on between the International Rail Union, our mission critical industry, through GPP and ETSI, and then what's now prevailing in terms of drawing through the solutions, getting spectrum, lobbying to get spectrum harmonized so that the lowest cost feature-rich solutions can be delivered across the world, and that we end up with a harmonized, standards-based solution that upon which all of the other applications and use cases can be based. So I think another one of the reasons that our members, TCCA and end users, can bring about this change and bring it about in a most expeditious fashion. So thanks for your participation today, Rory.
Thank you.
We had one more question from Barry around what is everyone's ideas on the initiatives for cybersecurity and resilience? If these MCX networks are easier to attack than classical digital closed PMR due to apps, etc., then what is the fallback if a cyber attack happens and a loss of service? I might take an initial swing at this because this is obviously, a very common topic coming up around the world, and is one that TCCA and our members and end users are looking at in the context of critical communications, and we're trying to assemble together. We have assembled a task force to look at this. We're now trying to gather some of the inputs from around the world to try and dissect what are the key issues, what are the core areas where industry and end users are requiring guidance, and where we should be devoting some time and attention. I'm just wondering whether you've got any comments, Neal or James, in respect to this, because I know the individual governments have been devoting quite a bit of time, effort, resources and money to improving the resilience of the digital networks, including the comms networks. Do you have any comments, Neal? And then maybe James, you might be able to add as well.
Sure, and it's just a small comment. I mean, this we spend a little bit of time looking at things like security around MCX and things. One of the things we realized is that the security threats are different, not always can be considered worse. I think that was one thing. You can imagine the security around your analog LMR network is kind of non-existent. It is very different, and it does require a brand new skill set for people who are involved in the deployment and maintenance and rollout of those systems, compared to other telecommunications and communications network. It's a very different skill set. So yes, it's one that's front of mind. So I don't have a very crisp answer for you, but it's a new skill set that's required for the industry to seriously focus on. And as Kevin said, it's an international problem that requires some international input around standardization to shut down some of those threat vectors that might occur. Thank you.
Yeah, James, I know New South Wales Telco has a special unit set up around this, so you might like to just make some comments around that.
Yeah, look, it certainly is a huge issue at the moment, and it was mentioned before about the Essential 8 legislation, etc., that we're all now being measured against. We report accordingly to our board on that. I think from this specific question about the use of applications, etc., and a greater reliance on data services, there has to be more protection that goes in to actually separate essentially the core network from the application layer, to make sure that if there are attack vectors there that are different, which are not seen in the critical comms space previously, that there's a layer of appropriate protection to make sure the core service remains up. I don't have a great deal of detail, that I can go into now as to how we'll do that, but it's certainly something that's forefront of mind.
Look, yeah, James, thanks for that. And I think, this is a common theme we're seeing across the world. And, the member organisations of TCCA are now trying to, I guess, collaborate on, what are the core areas that we need to, identify and provide guidance. And, it's clear that there's some good collaboration going from North America to Europe to agencies within Asia Pacific. So hopefully that's, some of the work from our task force will become apparent over the next 12 months. And hopefully by the time we get to Critical Comms World in Helsinki, there'll be a number of other insights that we may be able to share at that juncture. We have a few more questions around New Zealand. Has the digital LMR provider been finalised? Neal, I think the answer at the moment is you're still waiting for budget, but
yeah, so we're still finalising contracts, so it's not appropriate for me to probably disclose one of New Zealand's worst kept secrets.
Yeah, there's one other that probably should be directed to James. Is there anything more that you could possibly share on the PSMB POC, where that's at, what learnings, if any, so far?
I'll give a bit of a status update. So for those who are aware, the proof of concept was split into 4 different phases. So phases 1 and 2 have been completed, which involved a lot of lab testing. Phase 3, we're in about 60% of the way through at the moment, and this phase includes some of the multi-carrier roaming testing capabilities. So there's scenarios being set up to test across multiple states in Australia back to a common core. And then phase 4, which is also underway and about 45% complete, is looking at some of the interworking between LTE and LMR, and also working with deployments, etc. It's not due to be completed until later in the year, at some point in Q4. So I can't really go into specifics about the outcomes, if you like, just yet. But to provide some reassurance that the POC is well underway and nearing its completion stages and going well so far, which is all I can say.
Yeah, look, thanks, James. I think it's an important program, and I think the outcomes of this and the ability of this platform to demonstrate to some of the end user groups, what is possible and how that translates into functional and operational improvements is going to be really important. And I know that Australian Telco Authority have been intimately engaged with peers overseas who have been taking a similar path and sharing information to try and distill what might be the most appropriate outcomes for our region.
That's right. Yeah, we're taking a lot of learnings from networks and emergency service organisations across the world who have maybe a little bit further along this step than me. But I think the thing that's come out of that is that there is no one size fits all, and there's a number of things that we're having to test there that maybe are specific to the Australian environment.
Yeah. Excellent. Well, look, I think we've covered off all of the questions that have come in. The one remaining one was, will these slides be made available to all attendees? For everyone's information, this entire session has been recorded. Our intent is to share links to this recorded webinar with all of the registrants so that you will be able to retrospectively go back and view all of the content. So keep an eye out in your emails for links that will allow you to get to this webinar. And I'd like to take this opportunity to thank all of our presenters, to thank industry and our agencies for taking the time to prepare this webinar, and importantly, all of those that have attended and listened through these sessions. I hope you found the information insightful, and I truly recommend that you contemplate attending Comms Connect Melbourne and yeah, if you have the opportunity to go to Helsinki for our Comms Connect World in 2023, I would really thoroughly recommend, because the depth of information that you'll get through both the exhibitors and the conference programs is just amazing. So please follow those links and mark those dates in your diary. And with that, I'd like to thank you all again, and look out for our next CC Bitesize, and hopefully you can join us in Melbourne in October. Have a great afternoon, everyone, and thank you again for your participation. On behalf of TCCA and ACCF, if we can assist you, or you would be interested in getting membership, please drop us a line and we'll follow up with you accordingly.